Hi, I'm Varun Ganapathi from terminal.com. So what we do at Terminal is we make it really easy to use virtual machines in the cloud, super fast, and with features that no other cloud has right now. So one of the coolest features we have are that when you start up these machines in the cloud, you can essentially resize them, suspend them, and resume them, all without losing any of your RAM state. And it turns out that that feature is useful for a lot of different things. And also, our servers start up like really, really fast. So essentially, I'm just going to do a quick demo of how you can start up a server on Terminal. And also just note that you can run it on your own cluster as well. So you don't have to use our cloud. You can run it on EC2, on your own EC2 instances, on your own GCE instances, or your own like physical machines. So the cool thing is anything you build for Terminal can run anywhere. So that's another really cool thing. Actually, Ariel is here, and he shared this on Terminal, and so I'm just going to show. This is an example of k-fold cross-validation for model comparisons in DiPy. I don't actually fully know what that is, but basically, what's really cool is that he made a Python notebook. When he published it, we automatically capture the notebook state here. You can go through and like look at it. But then the really sweet thing is you can start it up, and when you do that, it takes like about 10 seconds. And when it's actually started up, the notebook is like exactly where it was before. It isn't like rebooting or like doing anything. It's just literally in exactly the same state. So you can see here it's like restoring the RAM. So what that means is you can basically go to the bottom line of that notebook and literally just start it up and like start typing. Like you can just do exactly what you were doing before. So that's like a really cool way of sharing stuff between people that has previously been quite hard. So I started up this notebook. Yeah, so here we go. We'll start it up. And the screen is narrower. So there you go. This is it's already running. I can go to the bottom line and like type something else, and it will work. So escape A, cool, and percentage whos. So there you go. So that's exactly the state where you left it. So with the same capability, we can do lots of other things. So if you notice, this was slightly slow when it started up, and that's because we were using the minimum possible size instance. This is like a mini, which is really small, slow, has like half a CPU, no RAM. What I can do with this instance is like, without any reboot, I can just go and be like, I want more RAM. So here, I'll just show you here. We'll do free-m, show you the RAM before, 800 megs. We'll go here. We'll say resize. Let's make it an extra large, 6.4 gigs of RAM. And then we'll type free here, and now you have 6.4 gigs. So that was like instantaneous. And the reason it was instantaneous in this case is because that machine that we have a bunch of machines, we're splitting them up ourselves. So lots of times we can do the resize instantaneously. But this would even work even if that wasn't the case. Like it always works. So we can basically hot migrate a machine from like one of these instances to another machine that's bigger and like resize it. So we can give you truly elastic computing like in seconds. So like basically right now on EC2 and other clouds, you sort of start up instances and you're like, oh, I don't want to shut them down because like I lose all of my state and then I like have to go and get everything set up again. Or oh, let me choose the biggest instance I'm going to use because like I don't want it to be slow. With this, you can like not have to choose. You can basically pay for exactly what you use and you can resize on the fly, which is I think really sweet. So that was one demo. Another demo is we're also trying to innovate a lot in the area of actually building a good terminal. So we believe that the future is most people are going to compute not on their actual laptop mostly. I mean, maybe they will for a lot of cases, but they'll eventually also want to be able to compute on some other machine that's not directly with them here. So that means we need really good interfaces that can deal with remote computing. And so we believe that the browser is going to be definitely one of like a very good way of doing that. And like HTML5 and CSS are going to make like the new terminal. It's like not going to be text anymore. It's going to be a full like interactive experience. And like with IPython Notebook, you already see that happening. We also built ourselves like our own IDE for Octave, which basically has a lot of cool things you can do. So you can basically surf peaks. Like I have like a 3D graphic here. One other cool thing is here, if I can do the full screen, cool. I can basically take this, start up another version of it. I can like send this link to a friend, and they can basically type, and I can type at the same time. We'll be able to see each other's graphic. I could do that, but it's like annoying to set up the windows. And the way that sort of thing works is you can basically just share access to your terminal. So here you can just type in an email address and be like, I want my friend Anurag to basically be able to work on this terminal with me. I'm going to share the IDE port with them, and like there you go, it works. And if there's some other port, like port 80, I can just do the same thing there. Or I can say, open up this port to everyone. So essentially, it makes it super trivial to essentially like export a web app like completely with everything running in it, totally working and like secure, and you can work with other people. So right now, I'll show snapshot. So here you go, just so you believe that this works. I'm going to change this thing. I'm going to do a simple, like this amazing plot, and I'm going to snapshot it. This snapshot is going to essentially, it's going to take like 5 to 10 seconds, and it's actually like dumping the entire RAM state, saving it, and like publishing it. And at the end of this process, I'm going to have a link that I can literally send to someone else, and they can basically start up exactly where I was. And so you just click start, and there you go. So like that's like the entire process. Like I created like a snapshot, shared it with someone, they can start it up. It's that fast. It's like, and it's one of those things where if you make an operation that's that complicated, that fast, essentially like you're going to do it way more, and you're going to integrate it into your process. And it's going to become something that's really going to help you in a variety of ways. So we've been hearing a lot about Spark like during this conference. So we were like, what if we just built like a hosted Spark platform? So we like did that last night. And so here you go. This is like the Spark manager. You like start it up. It has like the main node. I'm going to just play this video here, which shows like the entire thing. Takes about 4 minutes. So is it playing? Cool. So what happens is this thing is gonna start up a terminal. That terminal has the ability to like create other terminals on your behalf. So right here, this is actually created by Anurag. I could do it live, but I don't know, it's easier this way. And essentially, he's just gonna start up the he's gonna run a script, and that's basically gonna start up 3 nodes in the cluster automatically. Here we go. Let's fast forward. So start 3 or 4, I guess. So they're all going to start up. Our servers start up in about 10 seconds a pop. So like each one's just going to like spin up. And once it's up, he's going to switch to the master, and he's going to be able to use Scala interpreter and do like the thing that you do. There. I don't actually know this that well, but like we just tried to use it like last night because it sounded really cool. So here you go. It's creating all the instances. And so there you go. It's done. And so now what we're going to do is switch over to the master instance. So it's all graphical, so it's like really easy. He's just going to go up there. He's going to choose the first one, which is the master. We actually fixed the demo to actually have it be labeled now. But for now, that's how it works. So when he switches to the master, here he has like he can launch the connection to the Scala interpreter. And so we did this literally last night, so it's a little like rough around the edges, obviously. But here we go. So now we'll have the shell. I'll just skip forward. This is like the browser where he has like all of the different instances. He can type something up. So he's going to load a data file in, run it. Cool. So this is where things get really interesting. So like we have a Spark cluster. We're sharing this with other people. We decide like, you know, like we're not going to use it for a while. Like we don't want to like pay for it while we're not using it. What's really sweet is you can literally suspend the entire cluster with all of its RAM state to disk. So like now you're not paying for it anymore. You're just paying for the disk cost, which is pretty cheap. And that's like the way you would use Spark in like a multi-tenant setting. So essentially, just by using terminal, you get that like right away. So he's going to pause the entire cluster. I believe that's like the next line that he types coming up here. And so they're all paused, as you can see. Entire cluster is paused. So at this point, he's not paying for it. And now what you can do is just resume all of them. And the next thing he'll show is that literally because we keep the RAM state, he's going to page in everything that was in RAM on all of those Spark clusters back. And literally everything is cached just the way it was before, and he can just start using the interpreter again. So he can just keep going exactly without like where he left off, which is pretty sweet because that like basically what this lets you do is it lets you use the cloud elastically, but without like spending tons of money and like wasting resources, which I think is something like everyone cares about. Cool. There you go. So the next demo I want to show is, so we decided like, you know, IPython Notebook is pretty cool. Actually, we knew about IPython Notebook for a while, so I'm not going to pretend we did that last night. But basically, we like really think it's cool, and we've talked to Fernando a lot. And so this is like a hosted, I showed you the REL's like IPython Notebook thing, but we also we decided to do the same thing for cluster. So here you go. We start this simple snapshot. You start up. You just give it your API keys. The left side is like the instructions of what you do. You just put in your instruction, your API key, so it has permission to create things. And then after that, it's like pretty cool. So essentially, here you go. You use exactly the clusters tab as you would normally in IPython Notebook. You type in exactly how many instances you want. You click start. They happen. And there you go. And now you have like IPython parallel. I can like rerun all of these lines. I'll just run them all actually. And all of this is like live running on terminal right now with like 8 nodes that you have running. And what's really cool is like you can do a lot of the things like this when you don't have like a ton of data, or like maybe when something else like Spark is like overkill. This is actually a pretty good way of doing things because it's so easy. So what I did was I actually loaded in all of the data in this line. They're all living in a variable in each node's like namespace. Let me just explain more carefully. So this line here, map, I basically said run this process data function on every one of my nodes that are connected to this node. What does that do? It just says I'm going to make a global variable called myData, which lives in the namespace of that client, and then I'm going to like put in like 100,000 random numbers into it. Cool. And then I'm going to return my like ID just for kicks. So that's here you go. So you have like 7 of them. They've already loaded every data into memory. This line, I say, okay, cool. Process in parallel on all of them the max of that set of numbers. I ran that and then I plotted that like here. So that's like technically a map reduce or whatever. Now I'm just going to change that and be like, I actually want a sum. And it's pretty cool. Like basically all of that data was in RAM. It was still there, still working. I just like changed the function I called and it happened like right then. So it's like really easy to basically do like some very simple parallel operations on an entire cluster while keeping everything in memory. And of course the same techniques would work even if it were on disk. You can just save a bunch of files to disk. You could pull things from S3 and then process them and then save the data back to S3. So for a bunch of different parallel operations, like it's actually pretty easy to do it this way. I'm not saying this is like the way you would do everything, but the fact is like when you have less than 20 nodes, like the probability of a node failure is like really, really low. So essentially like it doesn't really matter if you're like resilient to a node failure. You can just like do it again. So it's like there's no real like reason to do something super heavyweight when you can just do it like easily. I mean, if you don't want to invest a ton of effort into like creating a big cluster. Cool, so that's cool. We also do lots of other things. So we're not specific to any one language. We're not specific to any one platform. We do everything. So this is RStudio Server. You can just, someone share this on terminal. You just click start and you have RStudio Server. This is like, it's like something kind of like IPython Notebook, but with a different way. So it's like, this is more traditional in the sense that you don't see a whole sequence of results, like code and like results and images intermixed. You just can, it's like a stateful thing. So you just click next here. It does plots. It's actually a really cool IDE, I thought. It looks really nice. It has like a lot of the features you'd want in IDE, and it's all running in your browser. And so what's awesome about this is we've now given you like an R server that you can pause, resume, and resize on the fly. And like that's pretty awesome. You can like do everything you could do normally with with terminal, just like with this thing as well. So basically, we've given you like hosted, like for most things, you can do hosted that thing like really quickly, which is pretty cool. This one I was also pretty excited about. This one is basically like a live X server running like in your browser. So this is like a terminal that's running, I'll just go recursive, and then like it's running terminal inside itself, like in the browser. And actually what's really cool is this one is actually, you can use this with 2 people at the same time, I discovered. I didn't make this, someone else shared this on terminal. So I can just like do that. Oh, whoops, I'm not like the same person. New incognito tab. Cool, and like apparently, like, so it's just like a shared X thing, like right now, which is pretty cool. So, so essentially, what we're basically trying to do is we're trying to build one piece of abstraction, which is this like really fast, lightweight VMs. They're based on containers, but they have like all of the features of VMs. They're like you can save the RAM state. They do disk block devices in a proper way. But like with containers, they're like resizable and they're very fast to start up and they're very lightweight. So we've combined both of those things together to make like a super lightweight, fast VM. And then now we're exploring like what are all the things you could do with that. And like there are a couple, like right now what we have is something like, it's kind of like GitHub but for like virtual machines, right? Like you can basically like fork someone else's virtual machine. You can start up their machine here. I could start it up. I can like change it and I can republish it, right? And that's pretty cool. Now at least we can like keep track of our computations. all our data sets. We can reproduce our research at any time. Any demo that we have, we can always go back to it. It's like not lost forever. We can basically, like, if a PhD student leaves, like, they can leave their research like there, and then like next PhD student can go back and like run it. Like, it'll actually work. So that's like all pretty cool. And I remember this when I was a PhD at Stanford. Like, this was like an annoying thing to deal with. But the next part that we're trying to solve, we haven't figured it out fully, is like the equivalent of merge and like modules for like these things. So like with Git, like, you know, you have like submodules and you have like merge operations, right? How do you resolve conflicts with like virtual machines, right? Like if you wanted to like re-merge two virtual machines together, like what would you do? Or like how would you make one virtual machine a module that like can be run from another one? And like how do you deal with like updating them on the fly? And these are open questions that we're like currently trying to figure out. We have like a couple of good ideas of how to do it, but like that's currently what we're working on. But we think that when we like figure all this out, or like we all together figure all of this out, like what will happen is that we can all make way more progress in like everything we're doing. Like when I want to write a paper about some new technique, like I don't have to re-implement all the previous techniques. I could just go start up their terminals for all of them, drop my data set in, and then just like run all of those algorithms on it and then compare. And there won't be any errors associated with like, oh, I implemented it wrong or something like that. Or like basically like all research will truly be reproducible. So anyways, that's like the dream that we're trying to aim for, and then like this is how we're doing it. So that's all.